Very good. Okay, guys, so make sure you can see. All right, if you think you're in a good spot, that's fine. Okay, but make sure you can see. So today is 2G problem solving with quadratics, and this has, I think there's two skills here, and the first skill is one of the hardest things that you can do in Year 11 maths. So the two skills we're going over is, the first one is finding the equation, or developing an equation for the problem, and this is the hardest skill. Alright, the second one is solving the equation, which we're going to start by doing manually and then we'll just use our calculator. That's a bit of cheese. Okay, so we know how to do this, but this is going to be a tricky one that I want to emphasise a bit today. So just when you're confronted with this kind of question in a test, there'll be two components to it. The first part will not be to find the equation, rather it will say something like, show, make an argument for us, demonstrate that this is the equation, okay? So you're given the equation, so you can still go ahead and get the marks for the second part of it, all right? So we always set it up like that to make sure you're not lost if you can't find the equation. So we're gonna do this over two parts. The first part, we're gonna go through the 3 examples in the notes, all right? And then we're gonna open up our textbook and I'm gonna start working through the questions in the textbook. At which stage, you're welcome to keep watching and pay attention, or you can have a go at them yourself, all right? But they're very challenging, okay? So I'm just going to go over the first part, how to develop the equation, and you know how to solve them yourself. Okay, let's get straight into this. So you can have a read of the process there. That's pretty much what I've written up here. It's going to be find the equation and then solve the equation. All right, so we've got 2 integers differ by 7, and the sum of their squares is 25. Find the integers. So 2 integers, that means 2 whole numbers, and they're different by 7. So if we let the first integer be x, then the second integer can be x plus 7. Okay, it's 7 larger or 7 less. And then we have the sum of their squares is 25. So what that means is x squared plus x plus 7 squared is equal to 25. Okay, so look, I just developed the equation in one step there, right? But to read those words and understand that and translate this to this equation, that's quite tricky. Okay, that's quite tricky. So 2 integers, we'll let x be the first one, and so the other one's going to be x plus 7, and the sum of their squares is 25. Excellent. Then all we're going to do, so that's part 1. We've found the equation. Next is to solve it. Now we'll do the first one manually, but following this one, we're just going to use our calculator. Okay, so what we're going to do is we're going to expand all of this and collect like terms. So here I need to use the perfect square rule. Okay, so looking along, I've got one lot of x squared, and I've got another lot here, so we can collect that. And I'm also going to move this 25 over. Alright, and the reason I'm doing that is so that we can solve this quadratic equation, right? That's how we do it. We make it equal to 0, and then we factorize it. So looking along here, we've got 49 take 25. What's that going to be? 29, 24. And we're just solving this quadratic. So I want to simplify it. I'm going to divide both sides by 2. Okay, because we can express it like this, 7x plus 12. Alright, we can divide by 2, and now that's something that's nice and easy for us to factorize. So we have x plus 4 and x plus 3 equal to 0. 4 times 3 will give you 12, and 4 plus 3 will give you 7. Apply the null factor law. Alright, so we've got x is minus 4 or x is minus 3. So we've got two solutions that satisfy this statement. But let's answer the question. It says find the integers. Okay? So if x is minus 4, then the other number is going to be minus 4 plus 7. Then the other number is 3. Okay, minus 4 plus 7. The other number is 3. And we're going to have, if we investigate this solution, if x is minus 3, then the other solution minus 3 plus 7, positive 4. Okay? So we've got two answers that satisfy this equation, right? X is minus 4 and 3. Okay, minus 4 squared plus 3 squared, that's going to be 25. Or minus 3 squared plus 4 squared, that will be 25. Both of them are different by 7. So they're the solutions. Okay, number 2. I'll have a sketch of it here, I'll separate. A rectangular paddock has a perimeter of 1,000 meters and an area of 60,000 square meters. Perimeter of 1,000. So what that means, I'm going to draw a rectangle. Perimeter, that means the distance around the outside is equal to 1,000. Okay, so what we're going to do is we're going to ascribe x to one of the sides. It doesn't matter which side we denote as x, okay? But if I call it this side, then this one has to be x as well, right? And we know that the total distance around the outside is 1,000. All right, so that means this side has to be 500 take x, and this side is equal in length, so it's 500 take x. Okay, so you might think, why? All right, let's show you. If we add up all of the sides together, what's the total length I get? 1,000. Very good. Okay, we can see 500 plus 500, that'll be 1,000. We have minus x plus x cancels, minus x plus x cancels. We're just left with 1,000. And so we've got the dimensions of this paddock where x could be any number, right? But we're told that area is 60,000. And so what that means is, if we think of an area of a rectangle, right, it's the length times the width. X times by 500 take x. X times by 500 take x is equal to 60,000. Okay, we've got the equation. All right, so we're going to solve this equation using our calculators. First, we're going to expand it. So we'll have 500x take x squared take 60,000. Anyone know their 60,000 times tables? Factors of 60,000. All right, I'm just going to rearrange it so it's like this: minus x squared plus 500x take 60,000 equals 0. And the reason I've arranged it like that is so we can see very clearly A is minus 1, B is 500, and C is minus 60,000. So once it's all been put to the left and all like terms have been collected, this is where we can use our equation solver. All right, so this is a skill we're going to need. It's going to be one we've looked at already and we're going to continue to look at. So pull your calculator out, we're going menu, we're going down the bottom to equation solver. We're doing polynomials. And the degree is 2. And then all you do is input the coefficients of A, B, and C and press solve. So I've got A is minus 1, B is 500, C is minus 60,000. Now, when I solve this, the solutions I get are x is 300, or x is 200. Okay, x could be either of those values. So let's investigate then. So, all right, first part, developing the equation, a little bit tricky. This is the algebra, okay, following the calculator, not too bad. But let's answer the question, right? It says, find the dimensions of the paddock. The dimensions are x multiplied by 500, take x. Well, if x is 300, then the dimensions are going to be 300 by, what's 500 take 300? 200. Very good. They're going to be the dimensions. Okay, we're going to see something interesting here. And if x is 200, then the dimensions are going to be 200 multiplied by 300. They're the same, right? Okay. If x, then we have 200 by 300. All right. So what are the dimensions? Whether you write it like that or whether you write it like that, make sure you include units. But the dimensions of this rectangular paddock are 200 meters by 300 meters. All right. So let's move on to the next one. So you can see we've got lots of different types of problems here, right? We had sort of an abstract one involving integers and the sum of their squares. Then we have one about a paddock. Now we've got one about a rectangular based box has a height of 5 centimeters and a volume of 280. One of the sides of the base is 1 centimeter longer than the other side. So I'm going to try and sketch that. So it's a rectangular box kind of thing. The height of it is 5. All right, so they're all 5. It's going back that way and back that way. And we've got the base. One of them is 1 centimeter longer. Okay, so if one of the sides of the base is x, then the other side is going to be x plus 1. It is 1 centimeter longer. And the volume, all right, the volume of a 3-dimensional rectangular prism is length times width times depth, right? And so the volume is equal to x times x plus 1 times 5, right? X times x plus 1 times 5. And we're told here, in this circumstance, the volume is 280. All right, so developing the equation, this is the tricky part, right? And so we'll work this out. That's going to be 5x times x plus 1, 5x squared plus 5x, take 280, 0. So we're going to put that in our calculator. A is 5, B is 5, C is minus 280. And I'll kilowatt. Okay, and we should answer in units as well. We've got rectangular box. Everything we've done is in centimeters. That was centimeters. So here we've got x centimeters. So our solutions are 7 and minus 8. All right, but there's something going on with those solutions. Think about the context of the problem. What have we found? We've found
you can't have a negative length.
Perfect. You cannot have a negative length. That doesn't make sense in the context of the problem. So there's a problem with the model. We need to reject this solution. Okay? Reject it because you can't have a negative length, right? So whenever models are beautiful, but models always have their limitations. And one of the limitations here is that this is not a solution that satisfies the problem. All right, so they're the first 3, okay? You can see developing the equation and then solving it. If you feel like you'd like to have a go at the questions in the textbook, please open up and get started. But otherwise, what I'm going to do up here is I'm just going to go through the first 9 questions and continue to talk about how to develop the equation. So, exercise 2G, open up your textbook. 2G, problem solving with quadratics. And all I'm going to do, I'm not going to solve them, I'm just going to help you develop the equation. Okay, so we should get through it reasonably quickly. So I'll clear a bit of space here on the board. Is anyone still writing this down? Very good. And at any stage throughout my explanation, feel free to just drop and continue with what you're up to. So, 2G question 1. We've got 2 integers differ by 12 and the sum of their squares is 74. So this one's going to be pretty similar to our example, right? We have the first integer being x, the second one being x plus 12. It's 12 units larger. And we have x squared plus x plus 12 squared. The sum of their squares is equal to 74. Alright, that's the first one. Number 2. The sum of a number and its reciprocal. Okay, so this might be where it's a bit challenging, is some of the words you can't remember. What does reciprocal mean? Well, if we have x as the number, then the reciprocal of x is 1 on top of x. Okay? So you might remember, where have we talked about it? We talked about it in the context of slope, right? If you have a line has a slope of 3, then a perpendicular line has negative reciprocal, isn't it? Minus 1 on 3. So the sum of a number and its reciprocal is 26 on 5. Okay, there's the equation for number 2. Number 3, the product of 2 consecutive even numbers. Alright, so the product, that means you're multiplying them. 2 consecutive. So consecutive means if you have x, then it's going to be the next number. But it's the next even number. The next even number. The product of 2 consecutive even numbers, so it's going to be x times by x plus 2. If you take any even number, 2, 4, 6, 8, the next consecutive even number is always 2 larger. So we're told the product of 2 consecutive even numbers is 360. Find the numbers. Okay, when you multiply them together, it equals 360. Okay. Where did I put the eraser? Number 4. The number of diagonals of an n-sided polygon is given by this formula. Alright. A polygon has 90 diagonals. Alright, so that just means a shape with how many lengths it's got going across the middle of it. How many sides does it have? So, the number of diagonals is equal to this, right? N on 2 times n take 3. And we're told the number of diagonals, this value d, is 90. Alright, and so there, that's a pretty easy one to solve. N is our variable here, but we just tend to use x, right? So don't be alarmed if there's a different variable there. Treat it the same way. We're going to expand that, move it over, and put it in our calculator, our values of a, b, c. Alright, we're on to some shape ones now. We've got some that are a certain shape. We've got number 5. The length of a rectangle is 4 centimetres longer than its width. And the rectangle has an area of 26. So if we go to sketch this, we have a rectangle. We call one of the sides x, and the other side is 4 centimetres longer. So it has to be x plus 4. And so then the area of this rectangle is x times x plus 4. And the area is equal to 26. Alright, so in a test, alright, it'll say something like, show that the area of a rectangle where one side is 4 centimetres longer than the other is given by this equation. Alright, and so you're going to make a bit of an argument as to why that's the case. Draw the picture, demonstrate from the picture. Okay, on to number 6. A rectangular box has a square base and its height is 1 centimetre longer than its base side length. Okay, let's break that down. Rectangular box has a square base. So the base is square. Alright, the base is square. And they've even given us that's x. Okay? And then we're told rectangular box has a square base. Its height is 1 centimetre longer than its base. So if this is its base and this is its height, well these distances are going to be x plus 1. They're 1 centimetre larger. Alright? Now, the total surface area, very good. Okay, so surface area is going to mean the sum of all of the surfaces. So it's going to mean all of the walls added together plus all of the bases added together. So let's make that argument. Total surface area equals base plus walls plus roof. Alright? Rectangular box is square base, total surface area. And the total surface area is 240 centimetres squared. So if we think about the base has an area of x times x. The base has an area of x squared. The walls, there are 4 walls. So I'm going to go, well, there's 4 of them. And each wall has an area of x times by x plus 1. X times by x plus 1. And the roof is the same as the base, so the roof is also x squared. Alright, do you see how this question says, show that the total surface area is given by this? And here, we're making an argument as to why that's the case. We've drawn the picture, and we're saying, well, the total surface area is going to be this. Here's the base, here's the walls, here's the roof. We're going to collect all them together, and it's going to be the exact same equation that they have there for us. 6x squared plus 4x equals 240. And then we can go ahead and solve it. Alright, so for number 6, it's provided for us. 6x squared plus 4x equals 240. Okay. Any questions? Alright, on to number 7. An open box can hold 80 centimetres cubed. It is made from a square piece of tin plate with 3 centimetre corners cut from each of its 4 corners. Alright, so we're making a box out of this net, right? We're going to fold up these edges. And we've got, these lengths are 3 centimetres. We've cut out 3 centimetre squares from each side. So read it again. An open box can hold 80 centimetres cubed. That's its capacity, its volume. It is made from a square piece. Find the dimensions of the original piece. Well, if we define the original piece had these dimensions, x times x, okay? Originally, it was a square piece of tin, right? Now we've taken away 3 there and 3 there. What's this distance become? If I've got x is the whole thing, and I take away 3 here, and I take away 3 here, they're going to be x takes 6. Very good. X takes 6. And so now the volume of this shape, so if that's x takes 6, if you're to fold up those edges, I'm going to draw it for you and show you what it will look like. Looks a bit like this. This is 3, and this is x takes 6. Alright, so the volume is going to be 3 times x takes 6 times x takes 6. And that's equal to 80. Alright, so we could be expanding, moving the numbers over, making it equal to 0. Solving. Alright, 2 more. Now this one's interesting because question 7, it doesn't actually ask you to find a solution, it just says, is it possible? Is it possible to bend 20 centimetres of wire into a rectangle with a length of 30 centimetres? So we're taking one piece of wire, here it is here, and it's 20 centimetres long, and we're going to bend it, so we're going to put 3 bends in it, 1, 2, 3, and see if we can make a rectangle with an area of 30 centimetres. Well, here's how we're going to check. It's going to be pretty similar to the question about the rectangular paddock, right? We've got a total perimeter, the distance the whole way around the outside is going to be 20. I'm going to define one of the sides as x, which means my other side has to be 10 take x. Alright, and so you can see this rectangle has a perimeter of 10 take x plus 10 take x plus x, just that equals 20. Now, sorry, you're good. Yeah. Now the area of this rectangle is going to be x times 10 take x. And the question is, can this rectangle have an area of 30 centimetres squared? So all it's asking you for, not the solutions, it's saying, is there a solution? How do we check if there is a solution to the quadratic?
The discriminant.
Discriminant, very good. If the discriminant is positive, means there's solutions. If it's negative, it means there's no solutions. So if you want, move it all across. If you put this in your calculator, once we've expanded it and moved it across, the calculator will say no solutions. So that's another way to check. All right. Okay, on to number 9. So this one's a little bit tricky. We'll have a chat about this one. We've got the rectangle ABCD is divided into a square and a smaller rectangle by XY, which is parallel to the shorter sides. Okay, so I've got A, B, C, D. And then we're going to have this here, such that all of those are equal. This is X, this is Y. Alright, the smaller rectangle BCXY, BC, they've got them round the other way, so I'll use the same notation they've got so I'm not getting confused. BCXY is similar to the original rectangle, such that that rectangle is in the golden ratio. The ratio AB on AD is called the golden ratio. Show that the golden ratio is this. Okay, and then we've got a hint there. Let AB, this distance here, equal X, and AD equal 1. This is going to be 1. Okay, so because they're similar, alright, so this requires a little bit of understanding of geometry of similar rectangles, similar shapes. It means their sides are in the same ratio. So that means AB divided by AD. Alright, AB, if we do this side divided by this side, it's going to equal, well, what side corresponds with AB in this rectangle?
YX.
Yep, YX, very good. It's going to be BC or YX. It's going to correspond with YX divided by YB. Okay? And we've declared AB is X. So we have X on top of AD is 1. Is equal to, what about YX? What's this length here? It's also 1. How about YB? What's this length? Anyone see? This whole thing is X. What's this length?
1.
1. So this has to be
1.
X take away 1, isn't it? The whole thing's X, and this is 1, then the remainder here is going to be X take 1. Alright, so all we're doing there, what have we said? They're in the same ratio. We've got AB, we've got AD, we've got YX is 1. We evaluated that from our shape here. And so now, this is the equation we're solving. Okay, we're going to cross multiply the denominators and put that in. Use your quadratic formula, I would, for this one. If you put it in, even if you put it in your calculator, it's still going to pop up with the same solution. Alright, that AB divided by AD is going to equal 1 plus root 5 on 2. Okay, so I'll stop there. The last one, quite tricky. But have a go, like I've showed you how we can develop these equations. What I'd like you to do now, what my advice would be, is turn the page, having seen how I've made the argument for it, try it yourself, right? We've talked about them, we've seen how they can be developed. Try and develop them yourself, and then find the solutions and make sure we answer with the solutions that are legitimate, all right? They're not contradictory to the question that's been asked. Very good. So this is a hard exercise, right? But we'll make sure we're very prepared when it comes around to test time for the question that will pop up in the test. All right, Stella?